Okay, now let's talk about algorithms a little bit. What is an algorithm? Now, an algorithm is a is a set, or not a set actually. It's a sequence. It's a sequence of well-defined operations that provide a solution to a problem. Provide a solution to a problem. Okay? So if you have a problem that you want to solve, and let's say you're teaching somebody else to solve that problem for you, what you do is you'll give a sequence of well-defined operations that that person can perform in order to solve that problem for you, right? Now, there are a few things to notice in this definition. Firstly, an algorithm is a sequence, okay? So it means it is a set of statements that have to be executed, a set of operations that has to be executed one after the other. It's a sequence, okay? So there is a well-defined flow in which the operations are to be performed, okay? The second part is well defined. The operations that you perform in order to solve that problem must be well defined. What do I mean by well defined? So the person or whoever is solving that problem, the operations that you provide, the sequence of operations that you provide must be well defined in their dictionary, which means they must be able to perform those operations. They must be able to perform those operations, right? So for example, let's take the next slide, which is the algorithm to make a cup of tea. So you're teaching your friend to make a cup of tea, right? So here are some things that you do in order to make a cup of tea. Okay? The first thing you'll do is, let's say, boil water. Boil water. Okay. Next, you put a tea bag in a cup. Maybe put a tea bag in a cup. Uh, pour water, right? And add milk and sugar, right? And 5 is stir, stir, right? So these are the 5 things that you do, let's say, in order to make a cup of tea. Now you are teaching this to somebody. Okay, consider a robot. You're teaching a robot how to make a cup of tea. So what you have is a sequence of steps, right? These are the sequences. They must be done one after the other. Now, some things in the sequence may be changed, right? For example, you may first put a tea bag in a cup and then boil water. You can do this as well. Okay. But essentially, you can change it, but once you have it, it must be done in this order. Okay. You have to boil water first before you pour the water. Okay. So when you teach somebody how to make a cup of tea, you would teach them a set of operations that they can perform. Right. So that's the first point we talked about. That's which is a sequence. An algorithm is a sequence of operations. These are the individual operations, right? Boiling water is an operation. Uh, Putting tea bag in a cup is an operation. Pouring the water is an operation. Adding milk and sugar is an operation. Stirring is an operation, right? So all these are operations, and what you have is once you have a sequence of operations, then you have an algorithm. And this algorithm solves a particular problem, which is to make a cup of tea. That is the algorithm to make a cup of tea, right? Now the second part of this equation is well defined. Okay, well defined operations. So in this algorithm, what you have is you have boil water, put a tea bag in a cup, pour water, add milk, sugar, stir. When you give this set of instructions, the sequence of instructions, sequence of operations to let's say your friend, you're teaching your friend to make a cup of tea. Now, when you give this sequence of operations to a friend, you know for a fact, or at least you assume that your friend will know how to boil water, okay, or how to put a tea bag in a cup, or how to pour water, right? How to stir. So these things are in your dictionary, at least. It's your assumption that these operations are well defined. Okay. Now let's say you are teaching a robot to do that. You're teaching a robot how to boil water, how to stir. Maybe these operations are not so well defined, right? Maybe the robot doesn't know what stir means. What does this mean, stir? Okay. Then you have to break this operation down into something that the robot can understand. So you'd say, stir is take a spoon. Take a spoon. That's let's say, you know what? Let's do this. Let's break this down into smaller statements. Let's say this is 5A. Take a spoon. 5B, right? Insert spoon into cup. I don't know. Into cup. 5C. Move the spoon in a clockwise rotating motion or something, right? Move the spoon in a clockwise motion or something. I don't know. I'm just making things up. Okay. So if now again, we are assuming that these operations are well defined in the dictionary of a robot, you know, inside the mind of a robot, these operations are well defined. The robot knows how to take a spoon, how to insert the spoon into a cup, right, into the cup, how to move the spoon in a clockwise motion, right? But maybe these operations are not required when you're teaching a friend, right? So what I mean is, when you are creating an algorithm for solving a problem which you then feed the computer, right? So when you are taking the help of a computer in order to solve a problem, you have to make sure that the operations that you give are well defined in the dictionary of the computer, right? So these operations that you give the computer must be understandable by the computer. Understandable by the computer, right? So that's one of the most important things of algorithms. And indeed, we will learn in this course uh, the concept of algorithmic thinking, the concept of algorithmic or computational thinking. Okay, algorithmic or computational thinking, which is how to think, how to think like a computer would think, okay, or how to think in terms of operations that the computer can perform, okay. Okay, now let's talk about the different parts of an algorithm. Generally speaking, an algorithm has three parts, okay. The first part is input, or taking the input. Next comes the processing, and finally the output, okay. Now, the input is not compulsory. You may have algorithms that do not take any input. Okay? For example, in the tea making algorithm example, we did not take any inputs, right? We just started straight away with solving the problem at hand, which is making the cup of tea. Okay? So an algorithm need not have to have an input. The second part is processing, obviously, which does the bulk of the work. And finally is the output, is which is the solution to the problem that you're trying to solve, right? So if we have to change our tea making algorithm so that it now takes input, what inputs can you think of? Okay, so let's say you want to pass some input to the tea making algorithm. What inputs can you think of? Now, you may have said one of the inputs can be the type of tea, okay, type of tea. So is it black tea? Is it green tea? uh, is it herbal tea? Okay, because because if you go back to the algorithm, right? If you go to the algorithm, I said put a tea bag in a cup, pour water. I should have added one more step in here, which is steep, right? Which is essentially wait, right? Steeping is waiting. That's it, right? You steep the tea bag in the hot water. So maybe you steep for 5 minutes. You can steep for, I don't know, 3 minutes, depending on what the type of tea is, right? Maybe you steep green tea for a lesser amount. You steep herbal tea for a larger amount of time, right? So maybe you steep herbal tea for 8 minutes. So one of the algorithms can be the type of tea, and your algorithm will change ever so slightly based on that type, based on the input, on that input. Okay, so these are all inputs. The second one that you may have thought of, if not, it's completely okay. The second one may be the number of cups of tea that you want to make, right? Number of cups of tea. So essentially, look at this. The algorithm essentially remains almost the same. What changes based on the input is the amount of water that you boil, right? Number of tea bags, number of cups, the the amount of the amount of steeping time, right? So an algorithm changes your so the input will change your algorithm slightly, but the basics, the sequence of steps, right, would remain the same. There would be small changes here and there. Okay. Sometimes the input or the inputs do not change the algorithm at all. Okay, and I'll give you an example of this. So in the previous example, we said that you can pass the type of tea as an input, right? So whoever's making the tea, let's say it's your friend making the tea, you may tell them, or they may ask you, what type of tea do you want? How many cups of tea do I need to make, right? So all these inputs will change the algorithm slightly, right? Based on the type of tea, you'll have different steeping times. Based on the number of cups, you'll have different amount of water to boil, different number of tea bags, different number of cups, different amounts of milk and sugar, different number of stirring actions, right? So you have to stir in each and every cup. Okay. Now, sometimes though, you would have an algorithm that takes inputs, but that does not change the algorithm at all. And I'll give you an example of such an algorithm. Imagine you have a coffee machine, right? You have a coffee machine. Sort of think about espresso machines or something. Espresso machines, a high-end espresso machine. Okay. So what the espresso machine has is internally it has an algorithm to make a cup of coffee. Let's talk about lattes. Okay. So it has an algorithm to make a cup of latte. So it first prepares the coffee, adds cream, maybe it does add sugar as well. It's like pretty high-end coffee machine. Okay. So what it has is an algorithm to make a cup of latte. So it's one of those coffee machines. Uh, think of this as a coffee machine. Okay. So one of those coffee machines that takes like coffee, that's one input, and water, that's another input, and it also takes milk. And what it produces is a latte. Okay. So internally it has the algorithm to do that, to take water, milk, and coffee and convert it to latte, right? Now the algorithm stays the same. Okay, every time you pass coffee, milk, and water, the algorithm stays the same. But in externally, you as a user can pass different types of inputs, right? So in coffee, you can pass decaf, you can pass blonde roast, you can pass dark roast, right? Milk, you can pass you know what, let me get rid of this. You can pass soy milk, right? You can pass skim milk. Okay, these are the types of milk that you can pass to this. Water, you can pass I don't know, tap water. You can pass, I don't know, if you want to pass sprinkling water for some reason, I don't know, you can pass it, right? It would taste horrible maybe, but you can pass it, because the algorithm does not care about the inputs. The algorithm does not care about the inputs. Okay, so if I had to summarize the algorithm and in the relationship between algorithms and inputs, what I would say is there are two types of inputs. There are two types of inputs. Okay, number one, inputs that change an algorithm, change an algo, but the change is very slight change. Okay, very small change. The second one is inputs that do not change. Okay, inputs that do not change the algorithm, inputs that do not change the algorithm. Okay, so you can have an algorithm that takes both these types of inputs. So on some inputs it changes itself slightly, on other inputs it's completely agnostic. Okay, it does not care about the input whatsoever. Okay, okay, now what I want you to do is think of an algorithm that finds the average of three numbers. So we have to come up with an algorithm that takes the average of three numbers. Okay, now as usual, any algorithm would have an input, a processing stage, and an output. Okay, so first question, what are the inputs to this algorithm? Okay, what are the inputs? What are the inputs to this algorithm? Now the inputs are these three numbers, right? Inputs are the three numbers that for which you want to find the average, right? The inputs are the three numbers. The second question is, how do we take inputs? Okay, so imagine you have a computer. How do you take inputs? So in terms of coding, we learn that in the next module, but right now all you can say is input the first number. So when you are writing that algorithm, all you would say is input the first number, or input a number, or you could say input the first number, input the first number, and so on and so forth. Okay, the third question is, what is the output? What is the output? The output is the average. That's the problem that we are trying to solve, right? The input are the numbers, the output is the average. The fourth question, and that's the one that you have to solve, is how do you calculate, how do you go from the input, which is these three numbers, to the output, which is the average of these three numbers. So this is the input and this is the output. How do you go from there to there? And that's what we have to do. Okay, now one thing to note is that an algorithm is a sequence of well-defined operations, right? Now when we find, or when we write the algorithm that finds the sum, the average of three numbers, what are the sequences of operations that we can assume that the computer knows. Okay, oh, sorry, what are the operations that we can assume that the computer knows? Okay, so in this case, I'll give you the operations. The operations that the computer knows are: number A, taking input, or I would say taking a single input from the user, taking a single input from the user. The second one is the operation that it can do is adding two numbers, okay, not more than that. The third one is dividing one number by the other. Okay, and fourth one is displaying a number. Now, imagine that you have been told that a computer can understand only these four types of operations. So these are the well-defined operations. Well-defined operations. Okay, these are legal set of operations that the computer can perform. So using these four operations, how would you write an algorithm to find the average of three numbers? Okay, so hopefully you tried that. You tried writing an algorithm to find the average of three numbers. I will give you my interpretation of such an algorithm. It doesn't matter if we have the same algorithm or not, but this is my interpretation of this. Okay, so the first one would be obviously input, right? The first phase of the algorithm would be input, right? And what are the input? So the first step is input A, input the first number. So this is where the user gives the algorithm the first number. Step 2, input the second number. Input the second number. Step 3, input the third number. Okay, why do we do this? Because in the previous example, in the previous slide, we said that the set of legal operations include taking a single input. Okay, we cannot take three numbers at once. We cannot take three inputs at once. We have to take single inputs from the user. Okay, so that's how we take the three numbers. Okay, now the next legal operations that we have to use are the addition and the division operators, right? Adding two numbers, dividing one number by the other. So the next step in this algorithm is processing. Okay, so step 4 is add the first and second numbers. Since we could add two numbers only, right? We cannot add three numbers. We only add two numbers. And what we can do is we can add the result with the third number. So add the result with the third number. Okay, and the result would be the sum of three numbers, right? So the next thing we do is we divide, right? We want to find the average. So what is the average of three numbers? Let's say the numbers are A, B, and C. The average would be A plus B plus C divided by 3, right? So the next step is divide the result by 3. That's our processing phase done. Okay, finally the output phase. The output phase consists of a single thing, and it uses this rule right here, displaying a number. Okay, so 7 is display the result. Okay, By the way, just to clarify something, so in this example, we said that a computer can take a single input from the user. A computer can add only two numbers, right? These are just sort of examples that serve as these well-defined operations. But in real life, at least in Python, you can definitely add more than two numbers. You can definitely divide. You can keep dividing. Okay, you can divide a divided by b divided by c divided by d. Okay, so you can do this. Internally, what happens is you first divide a by b, and then you divide the result by c, and then you divide the result by d. Right? If you add two numbers like a plus b plus c plus d, you can do that. This is a perfectly valid statement, right? So in our algorithm, we could have said add the three numbers, right? That would have been a valid statement. But internally, what Python does is it's a plus b, then adds the result, whatever the result is added with c, and then whatever that result is added with d. Okay, so just keep that in mind. You can definitely do that. So it's not like you can only add two numbers. Okay, it's not like you can only divide one number by the other, and you can definitely display more than one number at once. Okay, definitely do that. But this is just so that we know what an algorithm is and what the limitations of an algorithm are, which is an algorithm must remain in the domain of well-defined operators. Okay,